Just a reminder before we get started, if you like the content you see here and you want to see the entire mini course, you can gain access to this for free over on Skillshare by using the link in the description down below. That will give you a 1 month free trial of the premium membership and gain you immediate access to the full third-person platformer controller mini course topic over on Skillshare. Otherwise, the content will continue to upload weekly here in attempts to please the YouTube algorithm and keep the content flowing. With the very basics of the character movement implemented, we can move on to improving this somewhat with our animations. So we want to go to the meshes to begin and select one of our skeletal meshes. Right click on this, go to the create option and select the Anim blueprint. This will create a blueprint class specific to animations and it will be based on the skeletal mesh that we choose. Now, because both of the skeletal meshes that we've imported both make use of the same skeleton, this means that we can swap between the meshes and share this one blueprint. For naming conventions, you tend to have ABP for animation blueprint underscore something. So I'll just call this ABP underscore player. With that done, I feel this kind of belongs more in the animations folder. I'm just going to move that over to the other folder. We'll go into the animations folder and we'll open this one. And inside of this, we can see that we get a couple of different tabs open just here. A quick demonstration or example of what our player is going to be doing. And we have the animation graph, which we'll return to a little bit later to fill in the general flow of what should be getting driven into the final animation pose based on what the player is doing. And then the event graph to drive the logic, storing variables, very similar to any other blueprint. So the first thing that we want to do inside of the event graph is to store all of that information. We can see here it gives us a default try get pawn owner, which is going to check against the thing which is controlling this animation, which ideally is going to be the BP underscore player. Now I'm going to move this up a little bit. We have an update animation here, kind of running like an event tick. And we also have an equivalent to the begin play. So I'm going to find that by searching for the event blueprint begin play. This is the animation version. So that we don't need to cast constantly, I'm just going to cast and check if this is our BP underscore player. So we can do a cast to BP underscore player base, and we'll plug this in here. And as you're probably familiar from pretty much any other Unreal blueprint content, is we're going to promote this to a variable and use this reference to find our information a bit later. And I'll just call this one the player reference. By doing this here, this does make the update a little bit less safe because we may not have this information when we begin the event tick, essentially. So what I'm also going to do is a quick is valid check. So I'm going to control drag in the player ref. We'll do an is valid check from this. And this just means that we can cast once more if we don't already have this. I'm basically going to take this logic, control W and duplicate this down here. So if this isn't valid, we're going to try again and see if we can store this as a new reference. And only if this is valid, then we'll find the information about what our player is doing. A few very standard things we'll need with the player reference. So we'll control W to get another copy of this. The first one is going to be the velocity. So we're going to drive the idle, move, run animations and so on based on how fast we're moving or if we're moving. So if we just type velocity, we can do the get velocity function check. We probably don't need to know all of the directional information, so we can turn this into a float. So we'll do a vector length. If you were doing something a little bit more kind of in depth than we're going to go, where vertical movement might be important versus horizontal movement, then you probably would want to promote this to a vector. But I know for our examples that we're just going to be using a float check here, and then we'll promote this to a variable. I'll just call this one move speed. Again, just moving things into place to keep things manageable. The other thing that we want to know is rather than checking against this information to check the velocity vertically and horizontally and get all of that information, we can make use again of the character class and the variables that it's tracking to check if we're in the air, because we're going to want to swap between falling and idle animations if there isn't any movement going on. So what we're going to do is we'll get the player ref again and we'll pull from here and we'll check is falling. So we can get the Boolean from the character movement component, which is tracking constantly whether or not we are grounded. And this is kind of checking our vertical speed for us. And again, we'll promote this to a variable and we'll call this one B is in air. So because this is a positive return, this means that if we are falling, then of course we're in the air to be falling. So we'll just shorten that a little bit here. There are probably a couple of things we'll need to come back and add here, but for now that is pretty much everything that we've implemented based on our very simple movement paths. So we'll come back in a little bit later and probably add a couple of more things just here. With these values ready, we can return to our animation graph and start adding in these animations. We can check these values and drive what should be displayed. So we'll go to the Anim graph. Basically, what we want is a selection of checks to tell us what we will be plugging into the result output pose just here. Now, the first thing we need generally is going to be a state machine. We do this by adding a new state machine. We can press F2 to rename this, and I'll just call this one locomotion. This is our locomotion state machine, and this will basically be a selection of branches and checks to decide which state to enter based on the information that we're tracking. This is going to need to be plugged in here. And again, we're going to need to come back and do something a little bit later. We'll just remember that there's going to be something we need just here. So remember how to get to the Anim graph. If we drive the basic movement first of all though, from the entry pin, so as soon as we start playing, regardless of what's already been tracked, the first thing that we're going to want to enter is likely going to be a new state. And that state is going to be our idle or running information. We're going to assume that we start grounded. So I'll name this idle/run, and we can see if we hover over this, this is expecting an output animation to provide. So a really simple implementation of this for something like if we were to just assume that it's always going to be idle, would be coming into here, going to the asset browser, dragging in the idle animation, and simply plugging this in. Now this will actually work straight away, and you can see it's now showing what the idle animation will be doing, and it runs through this whole state for us. So it knows that because the only thing that we can do is come into the entry pin and go straight to idle run, that we're then going to always play this idle animation. So in fact, we can test this as we go along. If we go back to our player blueprint, select the skeletal mesh component, navigate to the right-hand side in the details panel and change the animation mode to the use animation blueprint if you don't already have that selected. You can choose between single animations, so all of the animations we've brought in could be used as well, but we want the blueprint in this case. And we're going to go to the ABP_player that we've just created. If we compile that and press play, you'll see that because again, it's the only animation we have, we now have our idle animation playing in the level, which is pretty cool. What we now want to do is we want to extend this a little bit because of course, if we were to begin moving around, we're just idling whilst we're running or moving. It seems as though I still have this in the swimming movement mode. So I'm just going to go back to the character movement, change the default land movement in case you left this to the same thing, and turn this back to walking. And then if we press play, we can double check that we are indeed sliding around, but in the idle pose. So we now want that to be updated to either walking, running, or sprinting, depending on the speed at which we're moving. Now we can do this rather than doing a bunch of branch checks or speed checks in our state machine. What we do instead is we can make something called a blend space, which will blend between multiple animations based on a value that we're going to be passing in. We want to create a 1D animation. So one-dimensional, we don't need to worry about a different kind of rotations or anything. It's just going to be a flat animation between either 3 or 4 different animations based on one speed. So we do that by going to animations. We're going to create an animation blend space. Now, blend space, the default version, will give you a 2-dimensional blend space, which will be for things like if you wanted to aim sideways and up, then you need to have a blend for the horizontal and vertical offset. We don't have that. We just have the horizontal movement of the speed at which we're moving. So we need a blend space 1D, and we need this to be based on the Devi skeleton. And we can call this one, I'll just call this one blend_idle sprint to indicate that we're moving all the way from idle to sprint, which will kind of encapsulate walking and running as well. If you wanted to be very detailed, you could say idle, walk, run, sprint if you wanted, but I think we can kind of shorthand this. So what we have here is our one-dimensional blend. We can begin this by dragging in the idle. So we know that the idle is going to be the very start point. If there is no speed being applied, then we're going to be in the idle state. Next, we're going to want to move to our walking. So if we're going a little bit faster than nothing, then we can shift and left click, and you can see that we're then blending between our idle state and our walking state. So then the next one is we're going to bring in the run. So I'm just left clicking and dragging. And if we left shift and left click, then we can drag this across from walk to run, seeing that we're just swapping from the full walk animation here to the full run animation here. And the final one is sprint. So I'm going to drag sprint right at the end. And if we left shift and left click and drag again, then we can drag this all the way to sprinting. So when we're at maximum speed, we're going to be sprinting. And what we'll be doing is we'll be using this blend space. So in fact, we can go back to the animation blueprint. We can see that we have the new option here, the blend idle sprint. Drag that in here, plug that in here, and we can get rid of the idle. So now this entire pose is going to be controlled based on this one blend space. We can see it's asking for a value. The value is a float. So we're going to use, of course, our movement speed. So the animation to be played is going to be based on the speed at which we're moving if we're grounded. Back in the blend, what we want to do is we have the axis settings here. We can drop this down. I'm going to name this one to move speed just to match the variable that's syncing up with it. You could call this anything. This could be velocity, horizontal movement, whatever you wanted really. But move speed just kind of makes sense to sync this up. Now the values here are a little bit small. 0 is a minimum. Of course, if this is at 0 down here, then we want to be an idle. 100 is a maximum. If you remember how fast the player can move, the maximum speed at the moment is on the character movement, which is 600. And that will be then multiplied by 2.5, which is the sprint offset. So what we actually want is the maximum axis on our blend space to account for sprinting as well as generally walking and standing still. So 600 times by 2.5 is 1500. So the maximum axis value is going to be 1500. So if we are moving and you're sprinting, then that should be the only time we should be able to enter in this value just here, which you can see has now been updated to a higher value in that small tab that kind of hovers when we're using this. So the next thing is making sure that we have these set up as we want them as well. So I think we should probably enter walking a little bit faster. Otherwise that looks a little bit slow, and I think we're going to reach this kind of speed quite soon. So we want to move this node down a little bit. So the way that we can do this, I'm going to hold left shift, click the drop down here for blend samples, and then click it again to drop everything down in one go. And what we want to do is we want to untick the snap to grid. Snap to grid basically means that when we drag this, we can only be on these grid lines, which are not too flexible. So for walking, I'm going to untick this, put this to a custom value of, let's say 150. That's going to feel, I think, a little bit more correct. So we reach the full walking animation at a speed of 150. And then I'd say the full running animation, it may be 600. So again, we'll need to unsnap the grid option there. So we can move this somewhere in between. And then 1500 will be our sprinting speed. So now that sets up our complete blend space to account for all of the different movements that we've plugged in. And if we save this, because we have that movement set up already, we're already tracking this movement speed. We're going to plug in this blend space, and then this is all going to be driven based on the velocity. And this is basically, as we're using our walk speed, the velocity is trying to reach this maximum walk speed that we're playing with. So if we press play, if I don't press any buttons, we can see that we go into pretty much a run animation straight away. If I hold control, then that's slowing us down and we do our walk animation. And if I hold shift, then we accelerate up to the sprinting animation. And again, that all kind of blends between them quite nicely. So the idea is that the system is trying to find a kind of midpoint between where the limbs are in the full idle and the full walk, or between the full walk and the full run. Is kind of making a somewhat procedural animation based on where the limbs are in the full versions and offsetting those midway between. And that makes everything look very smooth when we're going between different movement speeds in game. So I think that looks pretty cool. And we now have the basic movement in for the ground at least. Now this isn't accounting at the moment for jumping. So that does mean that we're just jumping off into space. And because there is some movement happening, we're playing the walking animation and of course floating off indefinitely. So I've probably turned off the gravity scale. So I'm going to turn this back to 1 as well, just resetting things from the previous topic. So now we can jump, we'll fall back down. but we will play the walking animation, which is fine. That is the next thing we'll be fixing. So we know inside of our locomotion, we have the basic state to check for, which is whether in idle or some type of grounded movement. What we then want to do is check whether we're just entering or exiting a jump, and then we're going to disable this from happening if we're in the air. So that's going to account for our vertical movement. The way we do this is we can drag from here and we'll place a new node. We want a new state, which is going to be, first of all, our start jumping state. You can see this one, because it's conditional, unlike the entry, where this is just going to enter this regardless. We now have this conditional thing, so if we double click into this, we can see that whether or not we can enter the start jumping. The entry for this is going to be very, very simple. We're going to control drag in the is in air boolean and plug this in. If we're in the air, then we're just going to assume for now that we're going to start jumping. So what we can do is we can come in here and we can provide the jump start animation. Now, the reason this has been split out is just to make the jump look a little bit more polished, rather than, again, kind of like with the mannequin, what we want to avoid is that messy looking jump where it kind of loops, where regardless of how long you're in the air, it just loops as though it looks like it kind of kicks out and then reloops the falling kicking animation. It just looks a little bit janky. So what we have instead is very simple, but we have a jumping up animation, which is the arms going up to imply that force. We have a air falling animation, which is a little bit more subtle than the mannequin. So we can loop this and it's not going to look quite as uncomfortable if you're in the air for a little bit longer. And then we have a jumping land as well for when we hit the floor. So we've got that whole cycle to account for the different states at which you might be in the air. So this is going to be one of those improvements we'll be making on top of the default character that you're provided with. Back in the locomotion again, we can now go from start jumping. So if we are in the air, we now want to check perhaps maybe how long we've been in there and then do our next thing. So we'll add another state from start jumping, and this will be our jump loop that we've just seen. So assuming that we're staying in the air for a little while, we're going to come straight into this and we will drag in the jump loop, or the air fall, we've called this one. So this is the one which is going to loop for as long as we are still in the air. And the way that we can drive this one, if we go back into the locomotion, again, that conditional check, what we can do is we can find out the remaining time that we have for our jump start. So if we type in jump start, we'll get a few different options here, and we can see we've got some information about how long that animation has left to play out. If the time remaining is less than a certain value, and we can come back and tweak this a little bit, but I found that something less than about 0.3 of a second left on the jump start animation is a good time to start playing this looping animation. Then we're going to merge into this one. We'll play this, and before it completely finishes playing out, we'll start considering playing into our jump loop. And then this, because we've got past the in-air check, for as long as we're in the air, this is going to kind of stay here. So one thing we do want to do is make sure that when we're inside of the jump loop, we're going to select this animation and double check that this is looping. And what we want to make sure it isn't looping is the start jump animation. So we're going to come in and we'll untick the looping. We don't want this to get stuck in this animation looping the start jump. We want this to play once, which is that initial launch, and then we'll let the state machine handle the rest. So these are very simple things to forget. So I just wanted to make a point of just considering whether you think you want an animation to loop or not. We've now accounted for jumping in the air or starting a jump, being in the air for a while. We now want to exit our jump. So we're going to pull from here. We'll add another state. We'll call this one end jump. And we can plug this straight into our idle run as well. We're going to need to account for both of these conditionals, and we'll also need to give this an animation. So when are we going to end jump? We're basically going to leave this state and enter this state when we're no longer in the air. So very similar to how we start jumping, it's just going to be the reverse. So if B is in air is not true, so not Boolean, plugged in here. So if we're no longer in the air, which means we've probably just hit the ground, then we want to enter this animation. This animation is going to be our jump land. And again, we only want this to play once. This isn't something which is going to keep looping. If you think of what the jump land looks like, just have a quick look over here. Obviously, we're not going to want that to keep happening for that one time that we hit the floor. So we're going to come in and we'll untick the loop animation. And in fact, looking at this, I think we probably want to account for this, or to have this account for the movement speed at which we're going. So we might want to make another blend space of this, but we'll see how it looks, and that might be one of the polish and improvement passes that we make. And then the final thing is we want to see if and when we're going to go back to the idle run. And just from testing, something that I find works quite well, very similar to what we've done previously. This time we're going to want to get the time remaining for the landed or the jump land animation. So we'll search jump land, we'll get time remaining. And this one is actually going to be quite lenient. We want this one to be quite a high check of 0.9. We'll plug this in and we will see how this looks. Now again, there are going to be a couple of things we want to come back and do. I think we probably will want this to be a blend space. We'll also want to account for wall sliding, but we haven't got to that part of the movement yet. We just want to make sure that we can get this core loop working. So if we press play, we can see how this looks. So we're still in the idle walk run animation. That looked okay. I mean, we're getting the launch animation. I think the falling looks pretty good again. Because it's more subtle, we can play that and loop that a few times and it doesn't look too bad. The falling animation, we're not getting the landing play at all. So maybe this is too lenient. Maybe my testing worked out in a slightly different way and we're going back into idle too soon. There we go. So now we're getting that landing animation. But this is what makes me think that we're going to want to add a blend space here. Because if we're moving, we kind of slide across and play the landing animation, which is what I thought was going to happen. So maybe something like the other value, maybe 0.3 here would be better. But I think we will want that blend space to maybe blend from the landing animation to like a slow walk or something. So rather than leaving that for a polish pass, because that does look a little bit rough. And we know that looks rough right now. So back in the animation folder, what I'm going to do, I've just been thinking about the way that this might work. And rather than just accounting for just hitting the floor, so that landing animation and a slow walking animation, I think we might be able to pick up enough speed that we could potentially be between running and sprinting. So what we can do is we can just duplicate, so Control W to duplicate the idle sprints. We'll call this one blend underscore, we'll say full land to walking. So some of these names can become a little bit nonsensical, but I think when you're inside, it's all going to make sense. Now this will be a little bit different. So we're going to want to untick, we can use most of this, which is why I think we can just copy this. We still want this to be driven from the move speed. We want to unsnap the idle. In fact, we can remove the idle. Yeah, if we remove the idle altogether, this would be the only thing which is different. And we can replace this with the jump land. So now we'll go from jump land to a slow walk. And you can see it's kind of offsetting the arms for us. So we're getting a nice kind of swing going into the walking animation, but still accounting for the landing animation. So it looks like we've hit the floor. And we can do that from all of these all the way up to sprinting. So we'll at least pass through this. This might be better as a 2D blend space, but I think that's going a little bit in depth for something you might only see for like a split part of a second. I think all of the speeds, they can remain pretty much the same. Keeping that from idle to jump land, I think will look pretty good. It's definitely going to look better than kind of sliding along the floor. So what we can do is we can go back into the locomotion, back into end jump, and when I replace this with our full land walking, I pulled the wrong one in. So we're going to get the full land walking, pour this in. And again, this is going to be based purely on the movement speed. So we can control drag this in, plug this into the move speed, and this will only happen when we're out of the air anyway. So when a grounded check has been made, and this is going to kind of merge back into the idle run. So it just means that we'll get hopefully a little bit of that animation going from the landing. Now, I think maybe that was why I want this to be higher if we're counting for blending. Okay, so we're not resetting something here. I think the problem we have is it was stuck here because we want to, again, make sure we don't loop this. So this is why it's important not to forget to unloop something. So we want to make sure that that comes out of that state and the value is being tracked. And we have some more bugs here to fix. That's fine. These are good sometimes to see these in production bugs so we can kind of debug through and see what's happening. So one useful thing to know is if we play from here, what we can do is we can see that this is going to show us what's happening as I play. So as I start jumping, I can actually see that I'm pressing jump and it's not getting up here. So we can find out why. We can go into the event graph and see what's happening over here. So I'll press play again. And we can see that as we begin, want to make sure that we're possessing the right thing. So this is the one that we spawned in, not one of the characters I had manually placed. So we are getting the correct values, which means we can now check in the locomotion. So I'm pressing running, I've jumped, it is going in, we're hitting that, and you can see that we're staying in the end jump. So this is where the problem is. And let's just take a look of why we might be staying in the end jump. So we're hitting the correct isn't air check that is being reset. I think the problem might actually be, if we go back into this check here, what we were doing is we were checking for an animation which is no longer being used. So we're checking to see when this ends. So we now want to make sure that we are checking for the full land walking. So we want the time remaining for the full land walking, and we'll plug this in. I think that might have been a really simple bug causing what looked like a serious issue. And there we go. So we're getting all of the states moved back around as we want them to be. I've jumped off the edge. And that is pretty much the basic movement setup done. So like I said, you might want to come back in and tweak around and play around with this value to get those different movements. Just bring this back in. But we now have the basics of our animation blueprint ready to go. So what we can do is we can then start coming back in and adding our more complex versions of the movement system. Because if you think about it, this is pretty much what a default template comes with, just a simple jump, some landing, and we've even got sprint and walking, which is slightly above what's provided by default. We can now come in and look at adding the more complex things like wall jumping, fixing our double jump system. So at the moment, we don't have the double jump animation playing, so that will be something that we could potentially do next. We can still double jump, but of course, there's nothing kind of indicating that we're still in the air. Now, the final thing is, just in case you forgot how to do this, we're still showing the capsule. I'm going to come into the capsule component. We'll go down to the rendering tab, and we'll make sure that we tick this to be hidden in game again. And we're pretty much in a playable state now. But that's looking pretty good for a first pass. Hopefully you've enjoyed that content, and just a reminder, if you wanted to get access to the full topics in this mini course, it's already fully available and uploaded over on Skillshare. I'm providing links in the description down below, which will allow you to sign up with a free premium trial. You'll gain full access to all of the courses over on Skillshare, including this 3D platformer focused controller topic. So be sure to check that out if you wanted to take advantage of the offer whilst it lasts. And as always, I just wanted to say a big thank you to all of the people supporting all of the work that I do here on YouTube, allowing me to keep making this weekly content. So a big thank you to all of the names scrolling down the screen.